Welcome back. So now to our final concept of this lesson, which now is the components of a circuit. We need to know firstly what a circuit is, what this electric circuit that we've been referring to, what is it? So this is now, a circuit is a complete pathway for electricity. So when electricity is moving from one point to the other in a complete closed circuit or in a complete closed manner, then we're saying that it is an electric circuit. Now for this circuit to function, it needs a source of energy, which normally we're using a cell or a battery. Remember that a battery that's now more than one cell, a combination of more than one cell. If it's just one, it's a cell. If it's more than one, then it is a battery. Now these cells that you're referring to, they have terminals, being the positive terminal and the negative terminal. So where do you find them? On this picture that we have here on this side, this negative here shows a terminal. It doesn't show electrons, and this doesn't show protons. So this is your negative terminal, and that is your positive terminal. And this device that we're seeing here, that is our cell. If I have more than one of these devices connected to each other, I now have a battery. A battery consists of more than one cell. So this thing, it goes from one terminal of a cell along conducting materials. Now, those conducting materials, we refer to them as your wire. So it goes from one terminal of a cell along conducting material through a device back to other terminal of the cell. So now the devices that we're talking about here, we're going to be looking at them individually from one all the way to the last one. So all we need to know is that the current, it is going from one terminal of a cell along conducting wires back to the terminal of a cell through a device, and then in so doing, this circuit must be closed. So for this electric current to move from one terminal to the rest or to the other terminal, the circuit must be closed. We also need to know what we mean by a closed circuit, and also can a circuit be open? We also need to know with that. So now, the circuit must be closed for a device to work, such as a bulb which lights up. So one of the devices that this electric current passes through is your bulb. And that bulb, for us to be able to know that electric current has passed through this bulb, the bulb is going to light up. So if it lights up, then we can clearly say that electric current, it did indeed pass through this particular device. So we can say that an electric circuit is a closed system which transfers electrical energy. So if someone asks you what an electrical circuit is, this is what you can say, that it's a closed system which transfers electrical energy from one terminal to the other, and it is passing through that electrical current, it is passing through certain devices. Now those devices, what are they? We'll start with the cell. Remember we said if there's more than one cell, we now have a battery. So the symbol for a cell is given here, that the short hand there, that shows your negative terminal, and the longer one shows your positive terminal. As we have said, each cell has terminals, the negative terminal and the positive terminal. As a shorthand to show what these things look like, we have these two notations here. The short one is your negative, and then the long one is going to be your positive. So now, electrical cells are the source of energy for electric circuit. We do know that these cells, they are supplying energy into the circuit. So they are the source of energy of the electrical circuit. So this energy that is being supplied by these cells, where does it come from? Where does this energy come from that is being supplied by these cells or by the battery if you have more than one cell? So inside the cell, there are several chemicals. And these chemicals, they store potential energy. We also need to know what potential energy is. Now, that's now an energy that an object has when it is stationary, when it is not moving. So therefore, inside the cells, there are several chemicals, and these chemicals, they store potential energy. Now, when a cell is in a complete circuit, the chemicals that are inside that particular cell, they will start to react with each other. And when they start reacting with each other, they will then give potential energy to the electrons. So as a result, the electrons are going to be given the potential energy that potential energy is what they need to start moving through the circuit. So remember that in order for you as an individual to move, you need energy. So these electrons, for them to move from one point to the other, they need the energy. That energy, where does it come from? It comes from these particular cells that you're talking about here. So now, when the electrons move, they have both the potential and the kinetic energy. Potential energy when it is stationary, and then kinetic energy when the object, or in this case, when an electron is in motion, it has kinetic energy. So the electric current, it is the movement of electrons through the conducting wires. So when someone asks you to define or to ask you what is an electrical current, you're going to tell them that an electrical current is the movement of electrons through the conducting wires. Remember, conducting wires could be any wire that is going to allow the current to pass through it. So wires, they have different conductivity, and we're going to be looking at those now. So another device that the electric current is passing through is going to be your resistor. So what is a resistor? As you can see from the picture here, there are certain objects that are wanting to pass through this device, and there's some resistivity that is happening there. So a resistor, that's an electrical component that limits or it regulates the flow of electrical current in an electrical circuit. So the resistor, it limits or it regulates, it controls the movement of electrical current through the electrical circuit, or in an electrical circuit. It controls the movement of this electrical current in a circuit. So these resistors, they allow electrons to move through them, but they do not make it easier for those electrons to pass through them. Hence resistor, they are resisting the movement or the flow of electrical current. So now, these resistors, they are said to resist the movement of electrons, as they getting their name from there, that they are resisting the flow, or they're resisting the movement of electrons from one point to the next. So as you can see from this picture, there's some resistance that is happening there. The electrons are not able to pass through easily. So the resistors, therefore, they influence the electric current in a circuit. So the resistors, they influence the electric current in a circuit. How do they influence that? Remember, the higher the resistance. If an electrical circuit has a higher resistance, then the electric current within that particular circuit is going to be low, because there is a lot of resistance happening there. So we're saying resistance, once the resistance is high, then the electric current is going to be low. So that means these two things, when one increases, the other one decreases. That is the relationship that they have. So in continuing now with the resistors, we are then saying now, these resistors, they can be extremely useful. How can they be useful? We need to think now about a kettle. If you look inside the kettle, you will see this large metal coil, and this metal coil, we know it is an element. So this metal coil is the heating element, and if you plug in and switch on the kettle, the element is going to heat up. So now when this element heats up, the water in the element will also now heat up. So therefore, the element heats up the water, and then the element is also known as a large resistor in this particular kettle. So when now this element is heating up, it is going to also heat up whatever the contents are inside that particular container, in this case, in this particular kettle. So how does that happen? When the electrons move through the resistor, they use a lot of energy. Remember, where are they getting this energy from? From the cells. The cells, or the battery, they are supplying the electrons with energy to be able to move around, or to move from one terminal to the other terminal. So when these electrons are moving through the resistor, that is this element in this case, they're going to use a lot of energy. Why are they using a lot of energy? Because the resistor is resisting the flow. It is resisting the movement of these electrons from one point to the next. So for these electrons to be able to pass through, to force their way through the resistor, they must use a lot of energy. So now, they are going to use this energy to overcome the resistance, because they want to pass through the resistor, but the resistor isn't making it easier for these electrons to pass through. So therefore, the electrons will then use up the energy that they have. So this energy is transferred into the surroundings in a form of heat. So when these electrons are using that energy supplied by the cells, that energy is going to be transferred into the surroundings and is transferred in a form of heat. Now, this heat is useful to us. Why is it useful to us? Because it is going to now be able to help us heat the water that's inside that kettle, and that's why we can then be able to boil the water and have our cup of coffee. In addition, with the resistors, we always need to remember that each of these components or each of these devices, they have a certain symbol. We saw that for a cell, we have a negative terminal and a positive terminal. Now, with regards to the resistor, this is what we have. It looks like a zigzag. So this is a symbol for a resistor given to us there at the top. Now, for us, we know what a cell looks like. We also need to know what a resistor looks like. So the picture here, it shows us what a resistor looks like. So now, the amount of resistance a substance offers to the circuit is measured in ohms, or it has a symbol omega there. So this is the symbol for ohms, and we are saying that all the resistance in a circuit is measured in ohms. You're going to hear people saying that this circuit has 3 ohms of resistance or 5 ohms of resistance. That means it has the resistance of 5, and the unit for the resistance is going to be ohms, and the symbol is that omega that is given there. So if you want to use resistors to control the current flow, then we need to know the amount of resistance. So in order for us to be able to use or to control the flow of current within a circuit, we need to know how much resistance is required for that particular circuit. And this is now why the circuits or why the resistors are useful to us, because as we have seen, they help us to heat up the water that we are able to make the coffee with. The light bulbs that are enabling us to see in the dark, that's now another form of a resistor. So now the colored bands that we're seeing here on this resistor, they are a code that tells us the resistance of this resistor. So as we have said, we need to know how much resistance is required or how much resistance we want in order to control the flow of current. So for us to be able to know that resistance, we're going to be looking at these resistors here. The colors given to us there, they are a code that tells us how much a resistor has in terms of its resistance. So we also have resistors where we can adjust the resistance ourselves. So not only just these ones, there are other resistors that we can be able to manipulate and adjust the resistance of that resistor ourselves. Now that resistor that enables us to adjust its resistance is called a variable resistor or a rheostat. It's called a variable resistor. So now, other components that are found within an electrical circuit, they are as follows, and these are their symbols again. We also have a switch. A switch can be open and a switch can also be closed. As we have said, a circuit can be a closed circuit or it can be an open circuit. So if it's a closed circuit, that means the electric current is then able to pass through from one terminal to the other terminal. However, if the circuit is open or if the switch is open, then current will not be able to pass through from one point to the other because there's an opening. The current will not be able to jump from this point and jump a space to go to the other one. So now, the other components of an electrical circuit, they include the switch. Now, the switch, as we have said, it can either be open or it can be closed, and we need to know what it means for a switch to be open or closed. So if it's closed, we're saying that it allows for the flow of current, or it allows the current to flow from one point to the other. But if it's open, it blocks or it disconnects the flow of electrons. And as we can see from the picture here, once the switch is closed, then the light bulb is able to emit light. However, once the switch is open, then the light bulb switches off because there's a disconnection. The electrons or the current flow is not able to move from this point to the other point if the switch is open, and if the switch is closed, then the electrical current is then able to use or able to jump from one point or to move from one point to the other. Now, in an electrical circuit, again, we also know that what is connecting the terminals, the negative terminal and the positive terminal, those are your wires, or in this case, our conducting wires. So now, that's a material which is usually metal, such as copper, and it allows the electrical current to pass easily. Remember, all of these metals or all of these wires, they have some sort of resistance. So we are going to use the one, or normally use the one that has the least resistance so that the electrons or the current can be able to flow easily through that particular metal. And now these are basically the symbols of whatever that you find inside an electrical circuit. We have a wire, we have a resistor, we have a light bulb, and this is our cell. And remember, if it's more than one, it's a battery, as given here. If it's more than one, it's a battery. If it's just a one, as you can see here, it is a cell. And then we also have our switch, and remember, our switch can either be open or the switch can be closed. So with that, we can be able to build our own electrical circuit. So with this information and all these components, let's see if we can be able to build our own electrical circuit. But remember, other sources, they use a different symbol for a resistor, which sometimes looks like this. So sometimes we'll find that a resistor is denoted as this, or it can also be denoted as a zigzag. So with this information again, see if you can be able to build your own electrical circuit, and I will see you next time. Bye.